So for this example, we will continue determining our probabilities. This is kind of a fun example. It says, at a pool party, there is a cooler filled with 30 cans of soda, 10 cans of Mountain Dew, 10 cans of Diet Pepsi, 5 cans of Dr. Pepper, and 5 cans of Coca-Cola. Reaching into the cooler, you randomly pull out 4 cans of soda. And then we have these two questions here. Don't forget our probabilities as we calculate them are going to be A over B, where A is the event in question. And of course, B is our sample space. So we'll use a combination, and I'm going to show you what results when we use a combination. So what is the probability that the 4 cans are all Mountain Dew? So the curious thing here is that they're all going to be the same. They're all just going to be Mountain Dew. That's what we're concerned with. So for B, our sample space, that's going to be 30. Choose 4. We have 30 cans of soda. We're going to reach in and grab 4. How many ways can we do that? Then the event is we want all the cans to be Mountain Dew. 10 cans of Mountain Dew, we want 4. 10, choose 4. Now we've stated in the past that since A is a subset of B, then the subscripts should tally up to equal the subscripts in the denominator, but all we have is 10, and here we have 30. But our 4 matches, but where's the other 20? Well, we have 10 cans of Diet Pepsi, but we don't want to choose any, so that's 10, choose 0. We go ahead and multiply that. We have 5 cans of Dr. Pepper. That's going to be 5, choose 0. And of course, we have 5 cans of Coca-Cola. That's 5, choose 0 also. So now as we look at our subscripts, 10, 20, 25, 30, of course, that's right there. And of course, 4, 0, 0, and 0, and that's right here. Now, 10, choose 0, that's just 1. 5, choose 0, there's only one way to choose nothing out of 5. And the same way with this 5, choose 0, that's 1. So for A up here, our event, that becomes 10, choose 4 times 1 times 1 times 1. Well, that's just 10, choose 4. So there's no need to include this. So I'm going to rewrite this. And the whole idea is to make sure that you're aware of what it is that you're doing. So we have 30, choose 4, and our event is simply 10, choose 4. Now 30, choose 4, that is 30 factorial, divided by 30 minus 4 factorial, that's 26 factorial, times 4 factorial. The 26 factorial will cancel out the 26 factorial up here in the numerator. So this is going to leave us with 30 times 29 times 28 times 27 over 4 times 3 times 2 times 1. For the event up here, that's going to be 10 factorial divided by 10 minus 4 factorial. That's 6 factorial, and 6 of the factorial are going to cancel out 6 of the factorial in the numerator. So that's going to give us 10 times 9 times 8 times 7 all over 4 times 3 times 2 times 1. As you can see, the denominator in the top half up here is the same as the denominator in the bottom half. So since they're the same, they factor each other out. Thus, I'm left with 10 times 9 times 8 times 7 over 30 times 29 times 28 times 27. And when you think about it, if I've got a cooler filled with 30 cans of soda and I'm going to reach in and pull out a can of Mountain Dew, I have a 10 out of 30 chance of that occurring. That's this right here. Then if I reach in again and I pull out a second can, and the probability of that one being Mountain Dew, that's 9 out of 29. Can you see that right here? If I reach in and pull out a third can, the chance of that being Mountain Dew, that's 8 out of 28. And if I reach in and pull out another can of Mountain Dew, the chance of that being Mountain Dew is 7 out of 27. So you don't necessarily have to do a combination, but even if you do, it winds out working out to be the same. Now, if you look at this, 10 times 9 times 8 times 7 over 30 times 29 times 28 times 27, that's the same as 10 permutate 4 over 30 permutate 4. And look at that. 10 choose 4 divided by 30 choose 4 happens to be the same as 10 permutate 4 over 30 permutate 4. But that's occurring because all the cans are going to be the same. Either one of these ways, you could go ahead and click it in your calculator. I'm going to use this way. I'm going to go 10 times 9 times 8 times 7. Then divide that by 30 times 29 times 28 times 27. And you can use your scroll keys to make sure you got it. Can you see it there? Go ahead and hit enter. And that's approximately 0.0077. We could also use our combination. 10, back to our probability key. Back to our combination. Choose 4. Then I'm just going to go right ahead and hit divide. 30. Choose 4. Hit enter. Comes out to be the same thing. We can use our permutations. 10, back to our probability key, but rather than hit our combination, I'm going to hit our permutation. Permutate 4. Divide that by 30. Permutate 4. So it's interesting how that works out because everything is the same. The cans are all the same. So this is also known as 0.77% probability. Now for B, it says, what is the probability that you pull out 2 cans of Dr. Pepper and 1 can of Diet Pepsi and 1 can of Coca-Cola soda? So since we have this mixture of cans, we don't have the luxury of simply doing it something like this. But we still have 30, choose 4. That's our sample space. That's B. How many different ways? Our event. We want 2 cans of Dr. Pepper. That's going to be 5, choose 2. One can of Diet Pepsi. That's going to be 10, choose 1, and 10 choose 1 is 10. And 1 can of Coca-Cola. So that's going to be 5 choose 1, and 5 choose 1 is 5. So then on our calculator, I'm going to do 5 choose 2 times 10 times 5, which is 50. Then I'm going to divide that by 30. Choose 4. And that comes out to be approximately 0.182. So we know that as 1.82%. And there we go.